We are going to be looking at solving things called rational equations. A rational equation is an equation that contains rational expressions. So anytime you have fractions with x's in the denominators or numerators, then you would have a rational equation. So, what does that mean? What do these look like? Let's look at example 1. We have some x's in fractions. Some strategies that we are going to use. Strategies. Get a common denominator. Because that's what you do when you add and subtract fractions. If you get a common denominator in a rational equation, then you can multiply to get rid of the fractions. So get a common denominator. So we're going to get a common denominator. We're going to multiply to get rid of fractions, because as soon as we get rid of fractions, our life is going to be easier, because then it's going to be solving an equation like you did in grade 9. Sometimes you might get quadratic equations, so you have to know how to factor or use the quadratic formula. But we'll be able to change our rational equations into equations that you already know how to solve. And if you can change an equation into something you already know how to solve, that's going to be good. Okay? As we're going through, we're going to list all non-permissible values, because sometimes you get an answer which you think is right, only to find out later it actually was a non-permissible value to start with. How do we find non-permissible values? Non-permissible values are whenever you're dividing by 0. So you have to check everywhere in your equation where you're dividing and find out where you'd be dividing, and is it possible that you're dividing by 0. So for example, let's start with A. In A, are we ever dividing by something that has an x? Yes, we have 1 over 2x and we have 1 over 10x. So do we have a non-permissible value? Is there something x can't be that would make you divide by 0? X can't be 0. If x is 0, then you divide by 0, and that would be bad. So I'm going to rewrite it. I'm going to leave some space beside each fraction, because I'm going to look at that first strategy and say, what would be a common denominator for all 3 of these fractions? 2x, 5, and 10x. Okay? Well, if you look at the numbers, just looking at the numbers 2, 5, and 10, we could get them all to be the same with a 10. So I could multiply the first one by 5 and 5, the second one by 2 and 2, and the third one's already 10, so that would be fine. Exactly. Then if we look at the variables, it needs to be 10x, right? So this one needs an x and an x. This one's already got an x. That one's already got an x. So if we rewrite it now with a common denominator, I'm going to have 5 over 10x minus 4x over 10x equals 1 over 10x. Once you have a common denominator, with an equation, what you do to one side, you do to the other side. And if I wanted to get rid of the 10x in my denominator on the right side, I would have to multiply by 10x. Now, when multiplying by 10x, if I multiply this side by 10x, I have to multiply the other side by 10x. Now, when I multiply this whole side by 10x, what it does is it distributes and multiplies everything by 10x. What's going to happen? The 10x's here are going to cancel out. When I multiply this 10x and this 10x, it's going to cancel out. When I multiply this 10x and this 10x, all the 10x's will cancel out. So making the common denominator, yes. They won't affect the 5 and the 4 because they will have simplified and canceled out. So now what do we have? What are we left with? We're just left with 5 minus 4x equals 1. Life is good. Because that's a question like a grade 9 solving question. Could you combine any like terms? Yes. If I move the 5 over, I would get negative 4x equals negative 4. And divide. And we have to check, was our answer our non-permissible value? No, our non-permissible value was 0. There is our answer. So this strategy, if we can get a common denominator, we can multiply to cancel it all out. And when we multiplied, even though there was 2 terms on our left side, when we multiplied that whole side by 10x, each of those denominators would get canceled out. So let's look at part B to see how it would work in another example. Again, I'm going to rewrite the question, leaving space beside each one. If I wanted to get a common denominator, x squared. So this one is missing. I'd have to multiply by an x. This one already has an x squared. If I wanted this last one, which would be like over 1, to also have an x squared, I can multiply top and bottom by x squared there. Now each of my fractions has a common denominator. I have 5x over x squared plus 6 over x squared equals 6x squared over x squared. Are we dividing anywhere? Yes. Do I have any non-permissible values? X can't be 0. Excellent. At this point, you could multiply this side by x squared and this side by x squared. I think for simplicity's sake, you could show your work this way. Multiply this side by x squared, that side by x squared. And then what's going to happen? All your denominators are going to cancel out with those x squareds. You're just going to have 5x plus 6 equals 6x squared. What kind of equation is this? Quadratic. How do we solve quadratic equations? We factor, but before we can factor, we have to make one side equal to 0. So, is factoring the only thing we could do? No. We could use the quadratic formula or complete the square. So sometimes if you feel like, this looks like one that's going to be hard for me to factor, you might want to choose to use the quadratic formula. If you feel like, you know what, I'm pretty good at factoring, I'm going to test this out, see how I can do. Okay, so if I go 2x and 3x, that would make 6x squared. If I put a 3 here and a 2 there, that would make 6 at the end. My inside is 9, my outside is 4. Does that make 5? Yes. I would need a minus 5, so I'd need negative 9 plus 4 to make negative 5. Do a quick multiplication throughout the whole thing to see if it actually factors correctly. And it does. And so our solutions Here, x could be 3/2, and here, x would be negative 2/3. Are either of those our non-permissible value? Nope. So this one is good, and this one is good. And we have two solutions. Well, the factoring part, if that's hard, then go to the quadratic formula. Okay, so try questions 3, 4, 5, and 8.